Hey everyone, this is lesson 1 in unit 10. We're going to do area. I do have some of the stuff filled in ahead of time because if not, the video would be probably like an hour long. So you're going to have to just stop the video as you go along, go at your own pace, copy down all your notes, and then just kind of take it from there. So if I'm going to go a little fast because everybody goes at a different pace, but you stop the video anytime you need to, and then again, write down the notes that you need and then take it from there. All right, so the do now says if the area of a square garden is 48 feet. So they're giving you the area of a square, okay? And they're telling you that the area of this square, okay, the whole area is 48, and then the square feet means feet squared. That's how you would write that out. What is the length and simplest radical form of one side of the garden? So they basically want one side. Now remember, a square, as you know, all the sides are the same. So some people like to use the formula length times width, or you could use side squared. That's the textbook formula. So if we say the area is side squared, which I already had, what do I have? I have the area. So the 48 goes into the A, and that's equal to side squared. Now what's the opposite of squaring? You know it, square rooting. All right, and it says leave in simplest radical form. So that was another hint to know that you're going to end up with a radical. So the opposite of, or the square root of s squared is s, and then two numbers that multiply to be 48. There's a whole bunch of them that multiply to be 48, but 16 and 3 we're going to use because 16 is a perfect square. So the square root of 16 is 4. 3 has no perfect square factors other than 1, so we're going to leave that as a square root of 3, and that's equal to the length of one of our sides. All right. So again, just do the best you can. If you don't have a calculator, trust me, trust my numbers, but if you do have a calculator, try it out on your own so you know how to get to it on your own. All right, I'm going to put this up here. Again, you're going to pause the video. You're going to copy down all those formulas. Area of a triangle is 1/2 base times height, or base times height divided by 2. The most important thing here is the base and the height have to be the perpendicular lengths. Rectangle, area, base times height. Some people like length times width. Area of a square we just went over. It's side squared. Some people like length times width. Some like base times height. At your level, you should really be using side squared because you're going to get questions like number 1. Area of a circle is pi r squared. So again, you're going to copy those down and have them in your memory. All right, so the next problem here, it says a rectangle. It has dimensions of 21.6 by 12, and the right triangle with base 9.6 and height. So remember, the base and the height have to be perpendicular, and that's cut out of your rectangle. Find the area of the shaded region. Well, how do you do that? You're going to find the area of the entire rectangle, and then you're going to cut out, subtract out the area of the triangle. So I started out with the process. I wrote down my formulas already, and now with you, I'm just going to put in the numbers. The length, 12.6, times the height, the width of 12, and then you're going to subtract out 1/2. The length of the base, they said, was 9.6. And the height was 7.2, okay? And that's equal to area of, I'm using SR shaded, S for the shaded, R for region. When you put this into the calculator, you get 259.2. You're subtracting 34.56. And then your final answer is 224.64 is equal to the area of the shaded region. All right, and again, I know I'm going a little bit fast, so you're going to have to pause the video, go back and relook at all these things, and just take your time. All right, what is the total area in cubic meters, and notice how all the units are given in meters, so that's good, of the irregular polygon. So what I'm going to do is I'm going to split this up into a rectangle, one rectangle, two rectangles, and then this is going to be my third rectangle, so that's where my formula is starting from. So the area of rectangle 1 is going to be 2 by 4. So 2 times 4. The area of my second rectangle has the same dimensions, 2 by 4. So we're going to add 2 times 4 again. And the third rectangle, the 9, represents the length of this entire side. And from here to here is already 4. So we're going to do 9 minus 4, which is 5. So the dimensions of this rectangle are 5 by 7. So 5 times 7, that's going to give you the area of your polygon. And when you do the math on that, it's 8 plus 8 plus 35. And that's going to give you an answer of 51. All right, so again, you're going to pause the video, write this all down, and make sure that you can get to it on your own so you can even try it again. You also should know that 1 foot is equal to 12 inches. All right, so notice here, these were in inches, 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 and the last DE was in feet. It said find the area of the irregular polygon to the nearest square foot. So I changed all of my inches to feet. So 21 divided by 12, you can check my math, 18 divided by 12, and 9 divided by 12. Okay, so I split this up into two rectangles. The area of rectangle 1, the length is 1.75, the width is 0.75, and that's going to be added to the length and width of this rectangle here. I just make sure I'm on screen. Okay, we're using 1.5 because they told us that DE was 1.5 feet. To find the length of DC, you had to take the entire length of AB. Okay, so it's going to be the entire length is 1.75. You're subtracting out the length of FE, and that's leaving us with 0.25. All right, so that's where I'm getting the 0.25 from. And when you do the math on that one, you're going to end up with 1.3125 plus 0.375. And again, I know I'm going kind of fast, but you're going to pause the video and go back again and again, and you're going to try these all on your own, and you're going to end up with 1.6875. And it said find the area to the nearest square foot. So we're rounding that off to the nearest square foot. So we're rounding it off to the 1. So since the next number is more than 5 or more, this becomes 2 feet squared, or 2 square feet. All right, and that ends up being your final answer on that one. So a little intricate. You're going to have to go back and just, look at all the numbers, divide it all out, and figure it all out, okay? So to find the length of DC, you're going to take the whole length of AB and then subtract out FE. All right, you guys got this. Okay, the next one is the picture frame. Kira has a square poster, okay? So square. We know that we're using... we're eventually going to be using the area of a square formula. All right, the poster has a diagonal. So the first thing we need to do is find the length of one of these sides. Okay, and we can do that by using the Pythagorean theorem. We don't have the area, but this is a right angle. We have the length A and B is going to be our x squared and x squared, and the C is always the hypotenuse, which is across in the right angle. That's going to be your 58 squared. Okay, when you do the math on that, you're going to end up with 2x squared is equal to 3,364. You're going to divide by 2. All right, I'm going to come up here, and you're going to end up with x squared equals 1,682. The opposite of squaring is square rooting, and you're going to find out that the length of each of these sides of the poster is 41. So the distance from here to here is 41. They told you in here that the width of the frame around the picture is 4 centimeters. All right, so that means that the length of the entire frame is 41 plus 4 plus 4, which is 49. That's going to be the same length here. So find the area of the poster, including the frame. So the area is equal to side squared, since the frame is also a square. So 49 squared, your area of the poster and frame to the nearest square centimeter comes out to be 2,401 centimeters squared. Okay, on the bottom here, what type of triangle is triangle ABC? Triangle ABC, because these are squares, the opposite sides of squares are all the same, so this becomes isosceles, 2 congruent sides, 2 congruent base angles. I sketched the perpendicular bisector, which forms right angles, and it bisects the base here, so 3 and 3. So determine the height. So what we're going to do is use that Pythagorean theorem again. So 3 squared plus x squared equals 5 squared. So 9 plus x squared equals 25. Subtract 9 from both sides. You end up with x squared equals 16. The opposite of squaring is square rooting. And you find the height to be 4. So to find the area of the entire shaded region, you're going to do the area of the square 1, 5 squared. The area of square 2, 5 squared, and the area of the triangle. The base is 6, the height is 4. All right, and when you do the math, 25 plus 25 plus 12, you end up with 62 as your final answer. All right, again, you're going to pause the video anytime you need to, and you're going to take your time on this. Last question in the accompanying diagram, they gave you that the altitude. Altitude is another word for height. It's drawn perpendicular from the vertex to the opposite side, forming a right angle. So find the area to the nearest tenth. So area equals 1/2 the length of the base, 5 radical 2 times the height, 4 radical 6. There's a couple of different ways to type this into your calculator. You could do the whole numbers, the outside numbers. 5 times 4 is 20. This is the square root of 4 times the square root of 6, which 2 times 6 is 12. All right, you could do 1/2 of 20, which is 10, times the square root of 12. And you could have just typed this into your calculator right from the get-go. Because I do want it to the nearest tenth. I'm just kind of giving you guys some options if you didn't have a calculator. You're rounding to the nearest tenth. So we're rounding to the 6 here. Since the next number is less than 4, your final answer is 34.6 centimeters squared. All right, so you're going to now work on the independent practice on your own. You're going to see how much you've got into your brain here. You guys are doing a great job. We miss you all. Lesson 2 will be posted tomorrow with another video. So take your time. I'm just going to put up the answers again just in case you missed any of that. All right, there's number 5 and 4 and 3, 2, 1. I will see you guys the next time around. Have a great day.